Well, hopefully that last problem gave you a lot of confidence instead of destroying it, which is what it usually does. But multiplying rational expressions. This, by the way, it's rational, which is just fraction multiplication. That's all this is. Don't let all the wording confuse you. It's just fraction multiplication. Oh, I thought it was going to end. There we go. It's just fraction multiplication. So remember in the past when you've done this, so it says completely factor each numerator and denominator. Show the numerators and denominators. What the heck? We'll do 20 divided by, well, 25 for now. I just want to keep it back to what you guys have done before. But let's say that was multiplied by something like 1/2. What the heck? We'll do 1/4. Okay. Well, in the past, they would say something like, hey, go ahead and take these and split them up into their prime factors. So 20, for example, here would have been 2 times 2 times 5. 25 would have been 5 times 5. And then the 4 would have been 2 times 2. The 1 is kind of fully factored already. And then what they would say is, go ahead and take these, and what we're going to do is we're going to find matches in the numerator and denominator. So I see this 5. Why am I starting with 5? I don't know. I just kind of did. And this 5, they match. I cross those out separately because sometimes they're not always above and below each other like we saw in that last example with binomials, right? So we say we're crossing these out, but it's just a slanted 1 because we can ignore ones that are being multiplied. I'll put 2 slashes through that. It's just so you can see I'm pairing this red 2 with this green 2. That's it. Okay, but it's still a 1. And same with this other 2. I can pair it with this other 2 in the denominator, right? Oh, that's nice. But what are we left with? Well, I'm left with 1/5. Okay, because I didn't have another 5 to pair this other 5 with. And so this is as simplified as I can make it. It's just now we're not going to see numbers by themselves most of the time. Sometimes we can with greatest common factors, but we're going to see these, instead of a 2, you're going to see an x minus 3, and then down here is an x minus 3. Cross it out because it goes away as a phantom 1. All right, same with sometimes they are pretty close to each other, above and below each other, so you can see this one would be like 5 plus x, and this one's 5 plus x. Cross those out because you can. They become phantom 1s, all right? And then you'll get something simplified, something, it won't look quite like this. But you'll have more fun doing it because you get to do it more in a different way. But yeah, that's what it's saying. Factor everything first. Factor your trinomials, your binomials, if you can. Factor them as much as possible. And then, yeah, you may have to re-show this. Again, I'm relating this to prime factorization because it does relate pretty directly here, even though not everyone would need that, right? Some people would just do cross simplification. That's fine. And then, of course, you find anything that can be any matches in the numerator and denominator that can go away as phantom 1s. Wanted to mention was that when you do fraction multiplication, it's just one fraction multiplied by the other fraction. That's it. You could put a multiplication symbol between, but it doesn't really change anything in terms of where you can pair things, numerators and denominators. Like this red 2 that I paired with this green 2, they're not even from the same fraction, but because they were multiplied, doesn't matter. So, yeah, so we've seen this already with the last example. You can simplify things. If you factor your binomials, trinomials, and you get some of the same factors in the numerators and denominators, the way I was just showing that, right, is we just kind of cross this out as a phantom 1. That was better. Okay, so that 1 right there in green, it's this 1 right here. But in the end, it's there, by the way. The multiplied by 1, it's still there. In fact, there's many multiplies by 1. They're just phantom 1s. I don't want to look at that garbage, so I'm not going to. So as simplified, right? Something times something. If you get something times the same thing from the numerator and denominator there, just ignore those things that match. You end up with whatever's left over, whatever is left over. Okay, so don't get overwhelmed. We're going to do this in 4 separate parts. How do you know it's 4 separate parts? Because there's 4 total parts to these fractions. You got 2 numerators, 2 denominators. I'm going to separate them and focus on them separately. okay? So we'll still come back to it, by the way, so I'm going to need some space there. In fact, I may need some extra space. Let's see, that's not what I want. Okay, so let's take this numerator here. And I'm gonna that's just from the numerator. I'm gonna do this part in red so that we know which parts are which. And let's factor this sucker. Okay, now my leading coefficient is a 1. That's convenient because I'm just gonna hold on, it's technology. Working now. So I'm expecting, all right, my two binomials, we're going to take the 2 and split it up into the factors of 2 times 1, which is 2, but also 2 plus 1 is 3, and so I know that my 2 binomials will be x plus 2 and also x plus 1. Now, if you don't have that memorized, because it was kind of a long time ago, and we didn't see too much of it in 4.7, or even, I think, 4.6, but you may have to do factoring by grouping until you can see that pattern, and then notice that you can take that trinomial and split it up that way. So going back, let's go back to the top here, right? I'm gonna factor these out, but I'm gonna end up with 2 fractions, right? Well, I just got that first numerator on the left as x plus 2, and then also x plus 1. So, by the way, for you nerds that are like, I really love this factoring stuff, look how many times you get to do it right here. You're going to have so much fun doing it. For those of you that hate it, hopefully we'll give you enough experience and then brainwash you into liking it. Well, not really, but in any case, I'm going to go to the denominator next. Okay, so that same denominator. All right, there we go. I got that set up. So this one I'll do in purple. So this part, right? Oh, okay, so this one, the leading coefficient is 1. It's a trinomial, so again, I'm expecting this to be just 2 binomials. We're going to have x's as the first term there, but I need 2 factors. This is -8. I need 2 factors of -8 that add up to -2. I'm going to use -4 and +2, okay? So again, the first factor there, -4, I'll put into the first binomial, and then the +2 goes in the second one, okay? So that's completely factored. And now I can put that into the denominator of that fraction. So I have it written as x minus 4 and then x plus 2. And just real quick, I set it up as x minus 4 and then x plus 2. Some students like to switch these just so the x plus 2s are above and below each other. It doesn't matter. You're going to get the same thing. You can they become phantom 1s one way or the other, okay? All right, next up, I'm going to go to the numerator of the second fraction. This will let me do it. There we go. Okay, and I look. So these 2 I didn't focus on any greatest common factors because I didn't see any of the 3 terms had x's, and I didn't see, and then the leading coefficient was 1. This one though, it's a binomial. If this x was squared, I'd be looking at maybe the difference of squares, but 5 is not a perfect square. So I should be looking right now at something that's a greatest common factor. I'll do this one in green. So I'm going to factor out from here, from 5 and 20, I know I can factor out a 5. So the first term, I factored out the 5, I'm left with the x. We'll keep the minus. It's really -20 divided by 5, though, which is -4. Okay, so that's my numerator of the second fraction. I've got 5, parentheses, x minus 4. Now, before I continue, I'm getting a little bit ahead of myself here, but the x minus 4 in green and the x minus 4 in purple, that means something. I'm going to wait to get to it as much as you want me to get to it right now or never. So I'm going to go now to the denominator of that fraction. I'll do this one in orange. It's a binomial with a leading coefficient that's 1. So I'm looking just to find 2 factors of -5 here that add up also to -4. From what I can tell, that should be -5 and +1. So that's going to be x minus 5 and also x plus 1. Okay, so that was the denominator of that second fraction. Let's get that in there. X minus 5 and then also x plus 1. All right, so you can see, you math nerds that are like, I love factoring, you just had a grand old time right there. But it's not done. It's not done for those of you that are like, I wish it was done. We're pretty close, though. We're pretty close, okay? So, we're just looking for matches in the numerators and denominators. We don't care where they are, as long as they match. But it has to be numerator and denominator. Some students are like, well, if they match in the numerators, then I can cross those out. No, because it has to be something divided by itself, okay? So, I see my x plus 2 there. There's an x plus 2. Again, those are slanted ones just to show that we are crossing them out, but I'm going to make those go away eventually, right? Then I notice the x plus 1 and this x plus 1. We got a red and orange one, numerator and denominator, so I can cross those out too. And then finally here, I've got an x minus 4 in green and an x minus 4 in orange. So those also will become a phantom 1. Now, as far as I can tell, that's as far as I can simplify this. What am I left with? In the numerator, we have that green 5. And then in the denominator, we have the orange x minus 5. Now I'm putting that in parentheses just so you can see it really just carries over. Some students don't like that because you don't really have to. Let's see if it'll look. There we go. Oh, crap. But just at the end here, do not, I'm going to say cancel out, which I don't like. Don't make those 5s a phantom 1 because you can't. This is a binomial, okay? But that's done. That's it. And for those of you that are hating this, remember the systems of equations with 3 variables? Yeah. I don't know where I'm going with that.